The arrival and continuity of Europe's first hominin populations raised two key questions. When did they arrive? And how stable was their presence? These are fundamentally demographic issues related to migration and population stability. There is general agreement that humans reached Western Europe between 1.5 and 1.4 million years ago. Some researchers suggest an earlier entry around 1.8 million years ago, while others argue for a later arrival around 900,000 years ago, influenced by climate changes. The demographic history of the Lower Paleolithic can be divided into two phases. During the Early Pleistocene, human populations were small and sporadic. Around 600,000 years ago, population density and distribution increased, accompanied by biological and cultural changes. However, settlements still remain discontinuous and clustered, with small, isolated communities persisting even after this period. This pattern is explained by Stablezor's populations thriving in favorable environments, while sink populations struggled to survive in harsher regions. In a broader Eurasian context, Europe itself functioned as a demographic sink, where populations were more vulnerable to environmental pressures and local extinctions. Europe is not a distinct continent, but a western peninsula of Eurasia, bordered by the Atlantic, Arctic, and Mediterranean. Migration in and out of Europe was common, making rigid geographic definitions unhelpful. Throughout the Pleistocene, climate and geography shaped human occupation. Glacial cycles altered sea levels, exposing and submerging land, while ice sheets limited northern expansion. Europe's varied topography, mountains, plains, rivers, and coastlines, further influenced human movement and survival. These environmental factors played a crucial role in shaping Paleolithic populations. The European Lower Paleolithic lasted from about 1.8 million to 300,000 years ago. It began with early hominin migrations from Africa into Europe and ended with the transition to the Middle Paleolithic. This period saw significant climatic changes, including shifts in glacial and interglacial cycles, which influenced human settlement patterns. The success of early human settlements depended on their ability to adapt to climate changes and compete with predators like large felids and hyenas. While some view early humans as passive scavengers, others suggest they were active hunters. Climate shifts played a crucial role in their survival, with human presence likely fluctuating based on environmental conditions. Hominin populations in Europe were unstable, with periods of occupation followed by population decline or disappearance. Early humans, such as Homo antecessor, were present around 1 million years ago. By the Middle Pleistocene, around 500,000 years ago, larger-brained Homo heidelbergensis appeared, showing advancements in toolmaking and adaptation to changing environments. Europe's geography and climate played a crucial role in human survival. Ice ages limited where populations could live, and migration into and out of the continent was common. Europe functioned as a demographic sink, meaning it relied on incoming populations to sustain itself, rather than having a continuous settlement. This period set the stage for later human evolution, influencing the development of Neanderthals and shaping early human adaptation strategies. Homo erectus migrated from Africa to Eurasia over 2 million years ago. Fossil and tool evidence shows they reached sites like Shangchen, China around 2.1 million years ago, Dmanisi, Georgia, by 1.85 million years ago, and Sangaran, Java, around 1.6 to 1.5 million years ago. Their movement was influenced by population growth, diet changes, and climate shifts. The Dmanisi site in Georgia, with fossils of at least 5 individuals 1.77 million years ago, suggests a sustained population but no clear link to early Europeans. The first confirmed hominin presence in Europe appears much later, around 1.8 to 1.3 million years ago, in sites like Piro Nord in Italy and Alto de las Picarazas in Spain. Most early European sites date between 1.4 to 1.2 million years ago, with tools primarily of the Mode 1 type. Human fossils are rare, found mainly in Spain. During the early Pleistocene, around 1.7 to 0.8 million years ago, human populations in Europe were small, scattered, and often temporary. Archaeological evidence suggests that early humans were present but did not establish large, continuous settlements. There are only about 23 known sites from this period, meaning there was roughly one site every 40,000 years. a very low frequency. During the early Pleistocene, around 1.7 to 0.8 million years ago, human populations in Europe were small, scattered, and often temporary. Archaeological evidence suggests that early humans were present, but did not establish large, continuous settlements. There are only about 23 known sites from this period, meaning there was roughly one site every 40,000 years, a very low frequency. Most of these sites contain only small collections of stone tools, usually fewer than 100 pieces, except for a few larger sites. Many of these sites were likely used multiple times over long periods, but it is difficult to determine exactly when and how often humans lived there. Instead of saying these areas were occupied, it is more accurate to say humans were simply present. Estimating the size of these populations is difficult. Some researchers suggest that the total number of early humans across Africa, Europe, and Asia was between 37,000 and 104,000 individuals, while others have guessed as high as 500,000. In Europe, population density was very low, likely around 0.07 to 0.10 people per square kilometer, although it may have been higher in resource-rich areas like the Iberian Peninsula. Despite their small numbers, early humans were more widespread than some other large mammals, showing that they were relatively adaptable. However, they faced serious challenges, including competition with carnivores for food and the risk of being prey themselves. Evidence from Dmanisi in Georgia suggests that carnivores may have scavenged human remains. The spread of early humans in Europe was uneven. Most sites are clustered in Mediterranean areas with milder climates, while very few are found in northern or eastern regions. This suggests that cold weather was a major barrier to human settlement. The Iberian Peninsula seems to have been the main entry point for humans into Europe, but even there, populations may have disappeared and been replaced multiple times. The discovery of the earliest human remains in Europe marks a significant milestone in understanding the spread of hominins from Africa. Two key sites in southeastern Spain, Barranco León and Fuente Nueva, provide compelling evidence of early human presence dating back approximately 1.4 to 1.6 million years ago. At Barranco León, located in the Guadix-Baza Basin, archaeologists uncovered a single deciduous baby molar attributed to a hominin, possibly Homo antecessor or an earlier form of Homo erectus. This discovery, alongside thousands of stone tools and fossilized animal remains, strongly indicates human activity in the region. Just 4 kilometers away, Fuente Nueva 3 has not yielded direct hominin fossils, but contains a vast collection of Oldowan stone tools and animal bones with cut marks, suggesting butchering activities by early humans. Dating between 1.3 and 1.6 million years ago, this site reinforces the idea that hominins successfully colonized southern Europe much earlier than previously believed. Both sites reveal important insights into the environment and climate of early Europe. Barranco León's discoveries were made in a freshwater stratigraphic layer, indicating that early humans inhabited areas rich in water sources. At Fuente Nueva 3, stone tools were found alongside remains of Mammuthus meridionalis, an ancient species of mammoth, suggesting that early humans engaged in hunting or scavenging. Fossil evidence from amphibians and reptiles suggests that these sites once had a warmer and wetter climate than today, characterized by hot summers, mild winters, and seasonal rainfall. The landscape consisted of dry grasslands, rocky terrain, Mediterranean shrubs, and scattered forests, providing an environment suitable for early human survival. Geologically, the Guadix-Baza Basin was once connected to the sea, but became land around 8 million years ago due to tectonic activity. Over time, layers of sediment accumulated, forming the uppermost stratigraphic levels where the Barranco León and Fuente Nueva 3 sites are now found. The presence of Oldowan stone tools, including large limestone implements and small flint flakes, demonstrates that early humans had already developed basic tool-making techniques to aid in hunting, scavenging, and survival. Their ability to adapt to available resources suggests a high level of flexibility in tool production. These discoveries support the theory that the Iberian Peninsula served as a crucial entry point for hominins migrating from Africa. Its mild climate and diverse ecosystems would have provided an ideal environment for early human settlement and adaptation. Recent findings at other sites, such as Cima del Elefante and Gran Dolina, continue to shape the debate on early human occupation in Europe. Researchers now explore whether human presence was continuous, limited to southern refuges, or subject to cycles of migration and extinction due to harsh glacial conditions. To resolve these questions, long and well-dated fossil records are needed, shedding further light on the complex history of early hominins in Europe. The Sierra de Atapuerca, located 15 kilometers east of Burgos, Spain, is home to some of Europe's most important prehistoric caves. These caves, formed in a limestone landscape, hold vital clues about early humans. Since the area lies between the Duero and Ebro River basins, it was a natural migration route for ancient people. Today, Atapuerca has cold winters and mild summers, with a climate similar to other parts of inland Spain. One of the most important sites in Atapuerca is Cima del Elefante, a 27-meter-deep cave. Scientists have found 21 layers of soil and rock here, containing simple stone tools and human fossils. Studies confirm that these layers date back nearly 1 million years, making them some of the oldest evidence of early humans in Europe. The most significant fossils found at Cima del Elefante, called ATE9, include a finger bone, a piece of an arm bone, and part of a lower jaw. These bones are estimated to be 1.3 to 1.2 million years old. Although they share features with Homo antecessor, another early human species from Atapuerca, there is not enough evidence to classify them into a specific group. At the time these early humans lived, Atapuerca had a mix of forests, grasslands, and rivers, providing plenty of food. Climate studies suggest they had to adapt to changing weather conditions, including dry periods and colder temperatures. Another key site in Atapuerca is Gran Dolina, a 17-meter-deep cave divided into 11 layers. Scientists studying these layers have identified a shift in Earth's magnetic field, which helps date the fossils. Excavations at Gran Dolina have uncovered human bones, animal fossils, and simple stone tools. One of the most important layers, TD6, is dated to around 900,000 to 950,000 years ago. The oldest layer, TD1, is about 1.18 million years old, though it does not contain human fossils. However, tools found in TD4, dated between 940,000 and 1 million years ago, suggest that early humans lived there. The fossils at Gran Dolina show how the environment changed over time. Some layers reveal shifts in animal populations, including the arrival of venomous shrews, marmots, and spotted hyenas in Europe. Studies suggest that during the Early Pleistocene, over 1 million years ago, the region had mild temperatures, around 10 to 13 degrees, and more rainfall than today. However, the climate changed in cycles. Some periods were cold and humid, while others were warmer and drier. Plant evidence from different layers shows that forests and grasslands remained stable, despite the ice ages. The TE9 and TD6 fossils represent some of the earliest known humans in Spain. The TE9 fossils include a small jawbone, a hand bone, and an upper arm bone. The jawbone has both primitive and more advanced features, showing that these early humans had begun to develop separately from their African ancestors. However, because so few bones have been found, scientists cannot be sure which human species they belong to. Atapuerca is one of the most important archaeological sites in Europe, giving us a glimpse into how early humans lived, adapted to changing climates, and migrated across the continent. Research is ongoing, and each new discovery helps us piece together the story of the first Europeans. The TD6 fossils found at Gran Dolina are among the most important human remains in Europe. These fossils belong to Homo antecessor, a species that had traits similar to both Neanderthals and modern humans. Their faces looked more advanced, while other parts of their bodies still had primitive features. Their teeth were more like those of later European humans rather than earlier African ancestors. Some scientists believe that Homo antecessor could be an ancestor of both Neanderthals and modern humans. Studies of the jaw bones, teeth, and arm bones of these early humans showed that they were different from earlier species like Homo habilis and Homo ergaster. Their teeth were becoming smaller and more modern in shape, while their arm bones had features similar to Neanderthals. This suggests that Homo antecessor was a key step in human evolution. Some scientists believe that saber-toothed cats left behind animal remains. allowing early humans to scavenge. However, discoveries at Atapuerca and other sites suggest that these early humans had a more varied diet and were likely hunters and scavengers. They used Oldowan stone tools made by chipping stones to create sharp edges. At some sites, like Vallenar and Barranco Leon, evidence suggests that hyenas did much of the scavenging rather than humans. However, in Atapuerca, findings show that early humans had better tools and more access to meat, making them more active hunters. The TD6 level at Gran Dolina also contains the earliest evidence of cannibalism, suggesting that early humans may have eaten each other in tough times. By around 1 million years ago, early humans like Homo antecessor had developed larger brains and enhanced cognitive abilities, allowing them to adapt to new environments and survive harsh conditions. Recent discoveries suggest that humans arrived in Europe earlier than previously believed, with advanced dating techniques indicating their presence before the 1 million year mark. Evidence from Bulgaria's Kozernica cave and France's Hérault Valley, with stone tools from approximately, supports early human habitation before 1 million years ago. In Italy, sites such as Piro Nord and Monte Poggiolo, together with Germany's Untermaasfeld site, suggest human activity around 1 million years ago. The UK's Happisburgh and Pakefield sites have the oldest known human footprints in Europe, dated between 900,000 and 850,000 years ago. Likely made by Homo antecessor, these footprints belong to a small group, including children, traversing a cool, forested landscape abundant with large mammals. Their existence suggests that early humans adapted to northern Europe's challenging climate much earlier than previously assumed. Later, more advanced stone tools, classified as Mode 2 technology, appeared in Europe. At sites such as Solana del Zamborino, approximately 0.9 million years ago, and Cueva Negra, around 0.76 million years ago. However, dating inconsistencies raise questions about their precise timelines. Researchers continue to debate whether early humans continuously inhabited Europe or experienced cycles of extinction and reoccupation due to shifting climatic conditions. Some theories suggest intermittent settlement, with small groups surviving in isolated refugia, while others argue that early humans were resilient enough to endure glacial periods. Despite evidence of early human presence in Europe before 1 million years ago, uncertainty remains about their continuous occupation. Some researchers question dating methods, suggesting key sites in Spain and Italy may be younger than estimated. Climate models suggest their presence was linked to glacial-interglacial transitions, as extreme cold and dense forests pose survival challenges. The lack of consistent evidence makes it unclear if they were permanent settlers or occasional visitors. The Cima del Elefante and Gran Dolina sites, at 1,000 meters above sea level, indicate early human adaptation to harsh winters. Southern Spain's Barranco Leon D and Fuente Nueva III may be older, with the Guadix-Baza Basin's woodland and water sources suggesting continuous habitation in the Iberian Peninsula for at least 300,000 years before 1 million years ago. However, early humans disappeared from Western Europe around 0.87 million years ago, likely due to climate shifts. Faunal evidence from Atapuerca reveals environmental changes that may have influenced different human populations and survival strategies. Recent discoveries from Atapuerca's TD6 site suggest Homo antecessor had closer ties to Eurasian hominins than early African populations. Some traits once thought unique to Neanderthals may have appeared much earlier and were inherited by both Neanderthals and modern humans. One key issue in human evolution is determining the most recent common ancestor of Neanderthals and modern humans. Genetic studies estimate that this ancestor lived between 0.34 and 0.85 million years ago. However, the fossils from TD6 seem to be even older than these estimates, creating a puzzle about how and when human lineages diverged. To explain these findings, researchers have proposed the central area of dispersal of Eurasia hypothesis. This model suggests that early humans may have spread from southwestern Asia rather than directly from Africa. According to this idea, a source population in Southwest Asia continuously inhabited the region and later spread into eastern and western Eurasia. This migration was influenced by changing climates, ecological conditions, and interactions between different human groups. Another interesting possibility is that some early human populations may have migrated back to Africa at certain points in history. Climate studies showed that the Sahara and Arabian deserts experience periodic wet phases, creating temporary migration corridors. During these humid periods, populations could have traveled between southwestern Asia and East Africa, allowing for genetic exchanges and new migrations. However, the fossil record from East Africa's Middle Pleistocene remains limited, making it difficult to confirm this theory. In summary, the antecessor fossil suggests that Homo antecessor was part of a larger Eurasian evolutionary network, challenging traditional views of human evolution. These findings highlight the complex movement of early human populations across continents, and the need for further fossil discoveries to better understand our past. The question of early human migration in Europe revolves around whether hominins continuously inhabited the continent or arrived in separate migration waves. If the Homo antecessor was part of an ancient European lineage, then the evolutionary split between modern humans and Neanderthals may have occurred over 1 million years ago. However, the more probable scenario suggests that antecessor hominins migrated to Europe later, originating from southwestern Asia rather than being the first settlers. A key debate is whether Homo antecessor arrived in an empty Europe or interacted with earlier hominin populations. Fossil evidence indicates possible links between antecessor hominins and later European populations, but the exact nature of this relationship is still unclear. If there was genetic mixing with earlier groups, it could challenge current evolutionary models. Another important clue comes from the stone tools found at the Grand Dolina site. These tools belong to Mode 1 technology, which is simpler than the Mode 2 tools that were already in use in Africa at the time. If the antecessor hominins had migrated directly from Africa, they would have likely used Mode 2 tools. Their use of Mode 1 tools instead suggests they had Eurasian origins, strengthening the idea that they came from southwestern Asia rather than Africa. The earliest confirmed human presence in Europe dates back to 1.4 to 1.5 million years ago, based on the fossil evidence. However, it remains uncertain whether Europe was occupied continuously or through repeated migration waves. Early humans in Europe adapted to harsh climatic conditions, possibly moving between warmer coastal areas and inland regions depending on environmental shifts. The lack of sufficient fossil evidence makes it difficult to determine whether Europe was settled by a single migratory pulse or multiple waves from the same source population. Future studies on the Grand Dolina cave site may provide insights into the relationship between TD6 hominins and later European populations. If there had been continuous human presence in Europe since the early Pleistocene, it could force a reconsideration of current models on the origins of Neanderthals and modern humans. There's an intriguing gap in the timeline between 900,000 and 500,000 years ago at the Grand Dolina. Curiously, during this gap, there are many remains of herbivorous animals, but it's unclear why humans seem to have disappeared from the area during this time. The earliest human occupation of Western Europe undoubtedly occurred before 1 million years ago. However, it's challenging to pinpoint whether this early settlement came from Africa or Asia, and the technology used at that time doesn't provide clear clues about its origin. This gap from 900,000 to 500,000 years ago isn't unique to Atapuerca, but appears to be a widespread phenomenon across Europe. It seems that the shift from the late Mode 1 technology of antecessor to the full Mode 2 technology of Homo heidelbergensis was not a local event but happened across the continent. Several hypotheses emerge from this observation. Firstly, it's possible that the Homo species similar to or an ancestor of antecessor that lived in Europe around 1.2 million years ago may have faced extinction around 800,000 years ago. It appears that Homo antecessor and related populations were not very successful in terms of population growth until the end of the early Pleistocene, around 900,000 years ago. They began showing signs of adaptability and growth, such as base camps, hunting, social cooperation, and food sharing. However, these strategies may not have prevented their extinction, and in some cases, cannibalism might have contributed to their population challenges. Secondly, the Acheulean technology, known for its large cutting tools like hand axes and cleavers, arrived in Europe around or before 650,000 years ago. This timing aligns more closely with an Acheulean tradition from northern Africa, suggesting a potential link between these regions. While there are no hominin fossils from European sites of this period, It's unlikely that Homo antecessor groups adopted this new technology due to their small numbers. Instead, it's more plausible that a different hominin group introduced the early Acheulean technology to Europe. However, these newcomers also had a small population, and the continent went through a significant depopulation between approximately 800,000 and 500,000 years ago, following the disappearance of the late Mode 1 and the earliest Mode 2 hominin groups. Around 500,000 years ago, a significant change occurred with the widespread introduction of the full Acheulean technology across Europe. This transition is marked by the increasing number of sites and intensive human occupations associated with this technology, and it's often linked with Homo heidelbergensis. Interestingly, this successful dispersal did not depend on the use of fire. There's no evidence of hearths or fire use at Atapuerca or other European sites. Even in the more recent levels dating to the mid-Middle Pleistocene, the general use of fire in Europe may not have become widespread until around 250,000 years ago. The absence of hearths at Atapuerca challenges the assumption that fire use was universal during this period and raises questions about whether this observation can be applied to the rest of Europe. Finally, the data supports the idea that the late Acheulean technology gradually evolved into the European Mode 3 industry without external influences. This transition aligns with the emergence of Neanderthals from Homo heidelbergensis, shedding light on technological continuity during this period. From a biological perspective, there's a shift from early Homo species and Homo antecessor, before 800,000 years ago, to Homo heidelbergensis from 500,000 years ago onwards. This suggests that late Mode 1 from around 800,000 years ago didn't evolve into the Acheulean of around 500,000 years ago, and the relationship between Homo antecessor and heidelbergensis is more complex than previously believed. The ancient human species Homo antecessor had a unique mix of primitive and advanced features. They had some facial traits that were similar to modern humans, and some features in common with Neanderthals and other ancient humans from the Middle Pleistocene. This suggests that these Neanderthal traits were present in Homo antecessor around 800,000 years ago and persisted in some Middle Pleistocene humans. However, these features are not found in other ancient human species like Homo ergaster and Homo erectus. There's ongoing research to understand the connections between different populations of ancient humans in Europe, Asia, and Africa. Homo antecessor could be a candidate for a common ancestor of Neanderthals and modern humans, or at least very closely related to that common ancestor. The fossil evidence from Homo antecessor is well dated, which is a rare and valuable aspect. However, it would be even more useful to find more complete skull remains in the future to study and compare with models predicting the common ancestor's appearance. The archaeological record from Atapuerca and other European sites suggests that the shift from early to advanced stone tools was a widespread event rather than a local development. Between 900,000 and 500,000 years ago, gaps in evidence raise questions about the fate of early human populations and the arrival of new tool-making techniques. The introduction of Acheulean tools and a subsequent population decline remain key mysteries in early European history. Around 600,000 to 500,000 years ago, human settlements expanded, particularly in Central and Eastern Europe, reaching sites like Misenheim, Schöningen, and Vertesjolös. Greece also saw its first confirmed human presence during this period. Early humans mostly settled near rivers and lakes, with caves becoming more common only after 500,000 years ago. Some sites, like Valle Jumentina and Cauna dell'Arago, were occupied repeatedly. A rise in stone tools 600,000 years ago suggests increased activity. Grand Dolina's TD 10.1 layer, for example, contained thousands of tools and animal remains. By the later Middle Pleistocene, sites like Boxgrove and Hoxne provide clearer evidence of human activity, though structured living spaces remain uncertain. Some researchers suggest shelters at Bildungsleben and Terra Amata, but this is debated. Schöningen, dating 300,000 years ago, reflects small, mobile groups that returned to the same areas, but left relatively few artifacts. Much of what we know about this period comes from river deposits, where tools accumulated over time. British river terraces suggest population changes, with peaks between 500,000 and 350,000 years ago, followed by a decline. Some researchers believe these shifts reflect changes in how early humans used the land, rather than actual population growth.